Well, hello and welcome again everybody, and you find me once again working on this Trio model 9R-59DS. Now I'm sure you remember from last time the problem that we have with this radio receiver is that it doesn't work on what they call band C. Now band C works between 4.8 megahertz and 14.5 megahertz, and well, it does work part way on band C, but then the local oscillator just stops working. And I'm sure I talked about that, pretty much probably bored you to death with all the spectrum analyzer action in last week's video. So this week really we're going to have a go at fixing the fault. But I think before I do anything too smart, we might as well just pull out this this oscillator valve, because it's in, well, it's an original valve. This has actually got the is it Kenwood on it? Well, it just says made in Japan, and it matches all the other valves which say made in Japan. Now I am going to try changing the valve, and I'm not expecting it to actually fix the problem, because I'll let you into a secret. I've actually already tried swapping it out with the valve here from the VFO, because it actually uses the same valve, which is well, for those in England it's an ECC 85. But I think for my American viewers, it's a 6A Q8, because they call them different things over the pond, don't they? So I pulled the oscillator valve out. No reason why it will make any difference, but we may as well give it a bit of a clean while it's off. The actual covering for the oscillator valve, it's actually very rusty and potentially making a bad contact. Again, don't think that'll stop it from working, but we may as well put another valve in. So here is supposedly this is a brand new valve. I actually bought this on eBay and it was described as new old stock, but to be honest the pins look a little bit bent on it and it doesn't look like a new valve to me, although I can't see any signs of heat on the inside of it. But I don't know, you can never tell when you buy these things off eBay. Of course they're always new valves, aren't they? Whether they are or not is a different matter. So let's try pushing that in. And I'm just going to take a little bit of emery cloth, and for what it's worth I'm just going to shine up the base on it so that it makes a really good connection here, because it has got some screening connections on it, and of course they are just for screening. But you never know, the capacitance, the additional capacitance around the valve, maybe it could make a difference. So we'll give that a polish and just maximise our chances of it working. Well, I'm afraid if this works it's probably going to make one of the shortest repair videos on the internet, isn't it? So fingers crossed that it doesn't work. So I've brought you back to have a close look at the circuit. So you can see that we've got a series of coils here. So starting from the bottom, that's for band B. Those set of coils and that capacitors for band B. This is for band C, where we've got the problem, and this is band D, which appears to work okay. So I'll let you know where my thinking is so far. I think I'll turn that sound down a bit, it's getting a bit annoying, isn't it? Now, I think if there was a problem with the main tuning capacitor here, sorry, the main tuning components consisting of this CT8 and L111, I think if there was a problem with those, the radio wouldn't be spot on frequency. You know, it'd be somewhere else. Well, between 14 and about 11 megahertz, this radio is spot on frequency. In fact, I've got nothing to make me think it's going off frequency. It's just that the local oscillator stops working. It does seem to be, while the local oscillator is working, it does seem to be tracking fairly well at the moment. So I would have thought that means it isn't a problem with L111 and CT8. I'd have thought it's also not a problem with the switch, because if the switch wasn't working it wouldn't work at all on band C. So at the moment I'm discounting the switch, but while we've got it apart we may as well chuck some switch cleaner in. So that leaves us with this 4000 picofarad capacitor here, which is C103, which actually feeds out the I'm guessing that feeds out the signal from these two tune components here. I don't know whether this 4000 picofarad would affect the tuning. I'm guessing it wouldn't affect it that much, because the main two tuning components are these two here. These are the resonance circuit, the parallel resonance circuit. So I'm thinking that 4000 perhaps wouldn't affect the tuning. But because it's a capacitor, of course it's going to pass higher frequencies better than it passes lower frequencies. So my thoughts are, is it a problem with this C103, this capacitor here? And we've also got a number of other components could be failing, but it seems strange that the radio works okay on band D, which is a higher frequency. So all these components work at a higher frequency than band C, and they also work at a lower frequency than band C. So I'm coming back towards this this series bit of capacitance here. If any of you've got any other thoughts on it, you know, channel me your wisdom, because I've got to admit I'm not exactly sure. Maybe the next thing to do is actually to measure some component values and see if these are what they say they are on this schematic. Well, as you can probably see, I've gone ahead and I've removed the bottom cover from the radio, and I've exposed this, which is what we call the coil box. Now the actual two tuned components for the parallel resonance circuit, that consists of this variable inductor here, which is labelled L111, and a variable capacitor, which is CT number 8, so that's that one. So there's the inductor and there's the capacitor. Now I've actually just had a quick look at the switch, and having had a look at the switch, I'm actually quite concerned at what I see. It appears to be very, very dirty and corroded looking. I'm guessing that from the rust on the back of the main transformer and some other spots of rust. I'm guessing that this radio has probably been stored in a very damp shed at some point, and of course that now tells a tale. Now I still don't necessarily think the problem is the switch bank, because it does appear to be switching into the band C, and it's certainly working at the top end of the band C. And I'm kind of thinking if the band select switch was a problem, it wouldn't enter into the band at all. But just the state of those switch contacts really is a bit of a state of concern for me. So I guess what we do is, as usual, we just grab the low hanging fruit, don't we? And we try and give them a little bit of a clean, because you never know, it could be something as simple as that and the fault might respond to cleaning. I'm not holding my breath, and I'm also not holding my breath that we can actually clean these switches in situ, because they just look so badly corroded. But let's have a go. Now I'm afraid I'll probably get in the way, but what I'm going to start with is, well, I think what I will start with is just putting some rag in to absorb some of this solvent that's going to go everywhere. So let's cover some of these components up. And what I'm going to do first is, I think I'm going to go in with some IPA. Now this switch wafer at the front there, this is the one that's doing the local oscillator. So I'm going to go ahead and I'm going to try to give those switches just a squirt of IPA, because I think the IPA, the alcohol, I think that it's got better kind of solvent properties maybe than the straight deoxit has. I'm thinking if I'm careful, maybe I can get at the back of some of the connections here, because it's kind of a double-sided switch. Can I get at the back? Sorry, my big head might be in the way. Now a good way to clean these things is actually to use you know, an old eraser, an indie rubber, something like that. But unfortunately I wouldn't be able to get that in here. Well, I think the thing to do is probably leave that switch for 10 minutes just to let the IPA cleaner evaporate off it. I don't actually think I've done much of a job at cleaning that, but I've not made it any worse. I was just terribly scared. If you go poking around in here, there's some very fine fingers that make contact, and they are very fine, and if you start trying to clean them, you run the risk of bending them. So if you're lucky, you'll just bend them and they won't make contact anymore. But if you actually snag one, it's very easy to break those contacts off, because after all these years the metal hardens and it cracks and it just breaks really easily. So these wave changer switches, unless you've actually got a replacement switch, they are the very devil to repair. Sometimes it's possible to, if you do damage one, you can maybe find a set of unused contacts on another switch, and you can take them off, but again they're riveted on and they're just difficult to put back, and of course there's no original spares available for this radio. Now the other thing that I'm battling with is a lot of the components, are right at the back of this coil box assembly, and I can't get at them. The only way to get at them is actually to take off the whole coil box, I think, and actually to take off that coil box is actually quite a lot of connections that have also got to come off as well, so that becomes a very, very big job, and I've got to admit I'm a little bit hesitant to do that. Well, I'm guessing our IPA cleaner, most of that should have flashed off now, so what I think we'll do is we're just going to put a little bit of switch cleaner in there, as much as anything, to lubricate it. So I've been quite liberal because I can't really see what I'm aiming at, so it's had a liberal squirt of switch cleaner there, and I'm working the switches. I'll squirt a little bit into the front control because it goes through a bush. A little bit in there, and I'm going to leave that to dry for maybe 10 minutes, because all that switch cleaner won't help the tuning on the radio, it won't help anything, and also it's probably a bit of a fire hazard, so we'll leave it 10 minutes for the solvents to evaporate, and then we'll give it another test. I don't expect that's repaired it, but you've got to try these things first, haven't you? And I'm feeding a signal into the radio at 10 megahertz, and as hopefully you can hear there, there's a tone. So it does actually work, this radio. I'm on band C up to about 10 megahertz. So what I'm going to do is I'm just going to reduce the frequency to 9 megahertz. So we're at 9 megahertz now. So if I just reset the tuning dial to 9 megahertz, if the local oscillator is now working, we should actually get a signal around 9 megahertz, shouldn't we? And we're not getting anything. Now I'm wondering if I can kind of do a bit of a two-handed job. Can I tune the radio around the 9 megahertz mark and also mess with the wave changer and make sure all the volumes turn fully up? Just wondering if we can get it to come back. Sometimes switches have a spot in them that's worn out, so if you actually just turn the switch very slightly, because they've got ball idents on here, little ball bearings that lock it into position, but if you just twist the knob very slightly, just rock it to one side of the ball bearing ident, the fingers will just be touching a slightly different bit of the wafer, so it will often be a clean part, that, and the switch can start working again if it's just a switch that's worn out. But yeah, still dead as a dodo. So let me just go back to our 10 megahertz, and our radio is still actually working, so there's a double blind check. So again, this oscillator is still shutting down at any frequency lower than about 10 megahertz. The local oscillator is just dying away. So I'm afraid we haven't fixed anything there by cleaning the wafer switch. Well, I guess while we're working on this switch bank, it would make sense just to actually check the resistance of these switch contacts, because that was the whole purpose of cleaning them. So this is the contact that I'm going to test now, which it goes between one end of this resistor, which is a, what's that? It's that 68 ohm resistor, R101. So it's going to go between one side of R101 and then one side of, I've got to follow it through now, and then one side of this capacitor here, this C103. So it switches between that point there and that point there. Well, that's showing a contact resistance of about 0.2 ohms, so and that's just the resistance of the leads, so I'm fairly happy with that. So that part of the switch is working okay. Well, I think that we've just verified as best we can the connection between this point here and there. Now what I wanted to do was now test the second part of the switch, which goes between here and these various inductors. So it was going to be that point there. Now the problem is all these actual inductors, they're actually all series together, they're all joined at one end. So it doesn't matter which switch I put the range switch on, I get a reading back to my own meter, so I can't really verify that these switches are working properly. All I can really do is check that we have continuity in each switch position. So I've gone ahead and I've done that, and I'm getting about 0.3 ohms in each of these four switch positions. I'm getting about 0.3 ohms between this point of the circuit here and this point, and as I say, effectively this point of the circuit is the same as that point is the same as that point, because these coils are all joined at one end to the earth line, so everything's shorted together. I think what I will do is I've written down what each of these components is, and I've looked up what the values should be. So I think that I'm going to go ahead and I'm going to try and verify all of these components, certainly the ones which are common to band C operation. Now unfortunately within the manual it's quite common, but there isn't any readings given for L111 and CTA. I don't know what the component values are, but nevertheless I don't suspect that there's a problem with them, because the radio is tuning spot on frequency when it's working. So I probably said earlier, I don't suspect a problem with that capacitor or that inductor, so I think it's going to be something outside here, and I think it's still probably my favourite is this capacitor here, which is C103, because if for some reason that isn't working as well as it should do at the lower frequencies, and you would expect that a capacitor, it's not going to pass as much AC as the frequency decreases. I really do suspect that that could be the problem. The reason I haven't jumped straight onto it is because it is a mica capacitor, and again they're just very reliable. So if there's a choice between a mica capacitor or a switch bank, I would generally always look at the switch bank. So we're going to check out that value of that capacitor there, see if we can measure it. We may or may not be able to, depending on these switch settings. And while we're at it, we're going to go ahead, we're going to check out the value of R101, which should be 68 ohms, this C47, which should be 240 picofarads, this 22k, and C12, which should be 3 picofarad. So let's go ahead and see if we can measure each of them. So we're going to take it that L111 is good, and its parallel tuning capacitor CT8, we're going to take it as read that both those capacitors are good. So I'm just going to put a tick against both of those. So the next one to test is CT103, which should be 4000 picofarads. Now I'm not sure if we're going to get a reading on this or not, because it just depends on the arrangement of the switches, whether it's being shorted out or not. And it's also very tricky to get at, because it's buried deep inside the set. And actually the body of the capacitor, I think it's this one here, that's probably not helping you, is it? But there's a capacitor and it's buried deep at the back of the wave change switch. So even trying to get my probes onto there isn't particularly easy. I think that might be on there. And it looks like the top of that goes to, I think it goes to there. Well, that capacitor should be 4000 picofarads, or in modern day money we'd say 4 nanofarads. Probably a matter of getting the switches in the right orientation. So I'm actually reading about 3.94 nanofarads. So I really was hoping to find a problem there, and unfortunately I haven't, because that was going to be my favourite. Now of course it doesn't mean it isn't breaking down under high voltage or something like that. It certainly could be, but yeah, I can't really test that at the moment, so I think we're just going to have to assume that that capacitor is good. So the next component I'm going to look at is R101, which should be 68 ohms, and I think I can use this little meter just to take that measurement. That's coming up 72 ohms, so I'm guessing that's in what tolerance is that? That's silver tolerance, so that's within 10%, isn't it? So 72 ohms. So make a note of that. So that appears okay as well. The next one is C47, so let me see where C47 actually is, because I'm not sure. Okay, C47 is actually connected to the end of this resistor that we've just checked, this 101, so we need to find a resistor. So there it is, there's our resistor, so I'm guessing it's that one. Where's the other end connected? The other end is connected up to the grid of our grid of our valve. So let's go on to that. It said it should be 240 picofarads and I'm measuring 260 picofarads. Does it make a difference what I have the band switch selected to? So it's slightly high, but I would have thought that's probably still within tolerance. So that looks okay as well, unless of course it's breaking down under high voltage, but one would assume it would break down for all the other bands because that capacitor is common to all the other bands. Now that 22k has also got our 3 picofarads strapped across it, so that's not going to measure. Okay, so that's slightly high. That should be 22k, but it's actually coming up as 27.46k. So the next capacitor that I was going to check is C13, which I think is a 10 nanofarad disc, and if I'm reading this right, it's a capacitor up there. There's no actual layout for this radio, and you know, you've got to kind of find your way around it, which is fine. You know, at least we've got some service data. It's better than not having any, isn't it? Now, I wouldn't have thought this capacitor would be the problem because this capacitor is common to all the wave bands. So if this didn't work, I wouldn't have thought it would work on any. However, interestingly enough, that is actually coming up as open at the moment. No, it's definitely coming up as open, that. Could do with trying to take it out of circuit, couldn't we? I think the first thing we'll do is we'll just clip one of the legs on it, the one that's easiest to get at, which I'm guessing is there. I'm going to clip that leg off it, and I'm going to put the meter back on and see if it measures any differently when it's out of circuit. Sod's law, it'll work perfectly now, which of course it does. Well, I've got to admit, I'm starting to head scratch now. Might be time for some groupthink. Now, of course, there could still be something wrong with these capacitors. It could maybe be passing DC or something when it's actually got high voltage on it, because we've only done low voltage tests. But I just can't see that somehow. Head scratching time. Well, I've got to admit, I'm getting to a point of somewhat frustration with this, in that I can't seem to find the problem with it, and it's one of them things where you wonder if it ever worked at all. It's such a strange fault. Well, oscillators stopping working aren't strange faults. It's a very, very common fault that an oscillator will just stop working part way across a band. But normally it's something like replacing the valve will actually remedy that. This hasn't worked. Now, I've been doing some more searching on YouTube, and this isn't my idea. Somebody else was describing a very similar problem to this that I was having, and apparently there's a bit of a thread. These have got a wax on them, these inductors inside here. They're coated in wax, and the problem that some people say is apparently the wax starts to go slightly conductive, and that can cause a problem. And the answer to that was to effectively to heat the wax up and scrub it off. So what I'm going to do is I'm using my hot air tool here, and that's what I'm going to do. I'm going to try and heat the wax up, and I'm trying not to put a ridiculous amount of heat into it, but I'm going to try and heat the wax up and see if we can wipe that off. What is it Sherlock Holmes used to say? When you've eliminated everything that's possible, you've got to look at the impossible, or something like that. Well, certainly I think I've looked at everything which I would consider possible, so I am now going into the realms of what I think's impossible. So as you've just seen, I've actually just removed as much of that wax around that inductor as I could. So we started off again, and I've got the radio tuned to about 12 megahertz. And again, we're looking at a local oscillator. So I'm going to start to reduce the frequency, and it kind of died away last time at about 7 megahertz. In fact, there's a marker that I've got set at 10, so we can hear that. And I would actually say that this marker is now actually louder than it's ever been. So you can see at 7 megahertz the oscillator's fallen quite a bit, but it's still existing, and before it had died away to nothing at 7 megahertz. So removing that wax has changed something. The oscillator's still running. Still got a fair way to go, but all I'm saying is we've made a change. So certainly removing that wax has helped. You know, the question is, can we actually remove any more and improve it any more? I'm really not sure. I think I've got off as much as I can, but yeah, maybe we can have another go. Well, you know what, I thought we'd hit pay dirt there. I thought I'd found the solution and that it was this coil and it was the wax on it. But as it happens, I cleaned everything down, came back half an hour later and had a cup of tea to find that the local oscillator had disappeared once again. But actually, I think it might have given me a clue to what's going on, because I actually used heat to actually make that start working again. I put some heat onto the components in here, and as you actually saw, the local oscillator was working, and I think that's what's making it work, putting some heat into it. So what I'm going to do is, I don't think I can get you in so you can see everything. Let me have a go. Oh, there it goes. It's hard to tell where I was directing the heat, that's the problem. So let me spray some freezer spray into it. And I think it's something in this switch bank. So I just gave a resistor a couple of zaps there. I don't think it's that resistor. Don't think it's that mica capacitor. There's another mica capacitor inside the switch bank. Let me try just hitting that. That appears to be working, doesn't it? Let me try hitting the coil itself. There's something in here that's responding to heat, but what? I'm just having trouble to spot it, because this freezer spray, it's quite a wide nozzle on it and it seems to just go everywhere. So this is the coil here, L111, that's the one that I've been hitting with the heat gun. And well, all I can say is, after another dose with the heat gun, it does seem to be up and running. In fact, we've never had the local oscillator running at this low frequency before. It's actually at the far end, the lowest end now of band C. It's actually off the scale, which is, it's on the 4.8 megahertz setting. So whatever we've done, putting some heat into this has affected a temporary repair. Will it stay permanent? I'm not sure. I'm just going to tune back the other way and see if we've still got the oscillator working at the other end, which we have. I'm going to leave this half an hour to cool down a little bit more. Well, it's about another 15 minutes later, and since we hit it again with the heat gun, it's actually stayed working, and unfortunately I can't really explain that. I can only put it down to it that we must have just knocked a little bit more wax off the off that L111 coil, because it did improve after that was heated up. Now it's actually quite warm in my room at the moment because I've had the heat gun going and stuff like that. So I think what I'm going to do is I'm going to leave this for another half an hour. I've already hit it with some freezer spray, so in theory, if it was going to fail due to cooling down again, it would have failed, but maybe there's something still running hot. So let's leave it for half an hour and then we'll come back. There's 5.5, I think the volume seems to have dropped a little bit, but we're still working. There's 5, and now we're at the bottom of the band, 4.8. Now I was being quite smug there, and I had fixed it for a while, but unfortunately I've the problem's returned, and it's just as bad as it was before now. It appears that when I direct heat into the back of the wave change switch, it all starts working again. And now I've taken the heat away, you can see it's falling. But it doesn't seem to be necessarily a mechanical problem. Let's go, it's back again. And now it's working perfectly. Okay, so I've just resorted back again to a cooling fan because it does seem to be firmly related, but it's proving very difficult to track down what the problem actually is.
Manchester, Metroport. Manchester at 1720 Zulu. Automated observation. Wind 190 degrees, 5 knots. Wind varying between 110 degrees and 240 degrees. Visibility 10 kilometers or more. Cloud, few at 2,900 feet.
Well, I'm sorry to say, everybody, that this old Trio 9R receiver, it really has taken us a full Jim Lindemus, and it's only taken me perhaps 2 or 3 days just to get around to changing a single capacitor. So let me show you what I've done. Well, if any of you want to wind back to the very start of this video, you'll see that I mentioned this capacitor here, which is C103, which is a 4000 picofarad mica capacitor, and it's in series with the two with a little tank circuit here with a little resonant circuit. Now this is the one we suspected all along, and the reason I suspected it is because it's in series with the output of this resonant coil here, and this is the sort of thing that obviously capacitors, as the frequency lowers, they actually pass less current through them, don't they? So what was happening, if this capacitor was failing, it would absolutely fit the bill. Now I actually did a test on it using the little Peak Atlas meter, but clearly that wasn't enough to actually detect the failure mode, because I've disconnected it from circuit, measured it, and it does measure pretty much bang on 4000 picofarads, but it doesn't work. Now unfortunately within my stock I didn't actually have another 4000 picofarad capacitor to change it out with. The only thing I did have was a 1000 picofarad, and the ceramics rather than the mica. So I've actually took 4 of those 1000 picofarad capacitors, and I've actually just strapped them in parallel with each other to make up approximately 4000 picofarads, and I've stuck them into circuit, and amazingly the radio now works perfectly. It will tune right from the highest part of the band to the lowest part. It doesn't matter if we heat things up or cool it down or switch it on a few hours later, it just works. So it looks like the source of my problems was this mica capacitor. Now unfortunately I can't point out the mica capacitor because it's buried very deeply in the back of the switch bank here, and you can't really see it. So actually changing this out is going to be a little bit of a trial, but I think we'll manage it if we're just careful not to melt all the surrounding wires. But I think for today we're going to call that fixed because it seems to be working very, very well. In fact, let me just turn the sound up for you.
You can think about, say, Africans who are being subject to various measures in China right now also.
Północno-namdelu azjatyckiego kontynenta odnośnie na zapadnej obali.
Fait du mal premièrement à la communauté magyare et crée des tensions.
So certainly, as you just saw there, it's tuning right from the top of the band right to the bottom of the band. So I am going to call this fixed as far as the tuning problem is concerned. Well, it's quite likely I'm going to have to put this radio into hibernation for just a few weeks because unfortunately I wasn't able to buy any 4000 picofarad capacitors in the UK. So I've actually managed to buy some old Russian 1% mica capacitors, but unfortunately they're having to come from America, so as soon as those capacitors arrive we will actually change them out. Now there's actually quite a lot of other work that we need to do on this receiver, so we've got the usual score of old electrolytics, and I believe that a lot of these are best change out, because I've seen quite a few people who've worked on these on YouTube and things, and a lot of these old capacitors do seem to have a bit of exploding quite spectacularly. So we're at least going to measure the ESR of them, and we may go ahead and change them out. I've got a feeling that the output, the volume from this radio really isn't as loud as it should be, and I do think it's probably got quite a lot of hours on it, so I'm going to be looking for maybe some replacement valves. We're also going to be looking at maybe doing the full alignment. And another thing that I've got to do is, just at this side here, you can probably see I've got a yellow wire bodged onto it. So this is an earth cable, because as it stands this radio doesn't have an earth terminal on it. So we're going to replace the 2-core mains flex with a 3-core and an earth, and just generally tidy things up. I said that these radios were very popular for modification, so what we've got down here is we've actually got a voltage stabilisation valve, and that's been quite badly wired in, and there's also a crystal oscillator used to align the frequency dial. Well, that, for whatever reason, that crystal oscillator doesn't seem to function either, and to be quite honest, I think I'd quite like to rip all of this modification out, because at the moment I've actually got the regulator valve pulled out, and this radio does seem to like running with a little bit of extra voltage. But I am going to maybe wire that back in, but if we wire in the regulator valve, I'm going to do a proper job of it, because the way it's been done, it's just a mess. There's also quite a lot of very poor solder joints and things up at the top of the receiver. What I'm saying is, I think we're going to take a break from this radio for a little while, but maybe when some parts arrive and when time allows, we'll have another dig into it. Well, you know what? I think for today, the wild goose chase that we've been on together has been quite long enough. So it's good night from me, and it's good night from him. Bye bye.
Too loud. I said that was too loud.
I want a trio and I want one now.
Yeah, well, we all do, man.